Yeah, you're welcome to our facilitation class once again today. The topic we'll be looking at today is soil forming rocks. Soil forming rocks. In other words, most of the soils we work with, or most of what we consider as soil, they came from rocks, came through certain processes from rock materials, thereby transforming into rocks. That is why we are talking about soil forming rocks. I remain Dr. Nathaniel Obasi, and of course, today should be the third week in our facilitation class. Keep asking you people to always endeavor to participate in our facilitation classes. Remember, we've also had a number of instructional videos which have as well been embedded into my course page. All you need to do is just go to the section, instructional videos, click on it, you see about 15 videos that have been recorded for this particular course, covering virtually all the units in the course. So as you join me in today's class, I want to assure you that you're going to have a very lovely time. Now, we say that although many of us don't think about the ground beneath us or the soil that we walk on each day, the truth is that soil is a very important resource. We imagine the possibility of Earth existing without soil. Even if we had rocks, but we don't have soil, do you think human beings would have survived? Do you think there would have been life on Earth? Because we all directly or indirectly depending on soil. Remember that the food we eat, they are products of agricultural practices which takes place basically on the soil. So you can now know how important the soil is to us. Because if there are no soils, then obviously we wouldn't be existing or even be alive today. Now, the processes that take place over thousands of years to create a small amount of soil material. So for soil to form, it takes a long time for a thickness, a little thickness of soil to form. It takes quite some time, quite some thousands of years to arrive at the soil we have today, which we now use. We build our houses on top of them. We grow our crops on top of them, and we even live on it, on the surface of the soil. So it takes quite some time, a long time, before these soils we have. Unfortunately, the most valuable soil is often used for building purposes or is even unprotected and is eroded or erodes away. Some of the soil, some of them very fertile soils, you see them being used for some other things. And all of that, some things such as buildings, build airports, build schools, we build stations and all of that on them. But these are quite very fertile soils. We hardly use them for what they should be used for. Now, to protect this vital resource, known as soil, and to sustain the world's growing house and food requirements, it is important to learn about soil, how soil forms, and the natural reactions that occur in the soil to sustain healthy plant growth as well as purify our waters. So soil is important to the livelihood of plants, animals, and humans. However, soil quality and quantity can be and is adversely affected by human activity as well as misuse. So soil can be misused. Soil can be, the quality of soil can reduce. Soil can be degraded. There could be, erosion taking place on the soil, eroding some sizable quantity of soil away. Remember, we said earlier that it takes a millennia. It takes thousands of years for a particular thickness of soil to form. However, just a single rainy season can do a lot of damage to the soil if that soil is not protected, if drainage channels are not well designed to take care of the flowing water from the rains and all of that, these soils may have serious problems. So the natural processes that occur on the surface of Earth, as well as alterations made to earth materials over a long period of time, form thousands of different types of soil. So we don't just have one type of soil, we have several types of soil. We have several types of soil, and those several types of soil we have as a result of several interactions and several compositions of the soil. So all of these put together are what bring about the formation of the different types of soils that we have today. For instance, in the United States of America alone, there are over 50,000 different soils. Specific factors are involved in forming soils, and these factors vary worldwide, creating varied soil combinations as well as soil properties worldwide. So many factors contribute to what leads to the formation of soil. And some of those factors, in a way, also determine the type of soils that are formed, as well as the type of characteristics that these soils exhibit all over the world. So now we talk about soil forming rocks as well as minerals. Soil forming rocks. Now, when we talk about soil forming rocks, the formation of soil happens over a very long period of time. It takes quite some time before soils form. As I said earlier, it takes a millennia. Sometimes it takes more than 1,000 years for soil to form. Now, if that is the case, that it takes quite such a long time for soils to form. Soil forms from a particular, event, a particular happenings. Soil don't just form. There are things that must happen before soils will form. And those things that happen, the collective name we give to them is weathering of rocks and minerals. Weathering of rocks and minerals. Now, when we talk about weathering of rocks, remember, minerals, there are some, what actually constitute the component of the rocks are minerals. There are different kinds of minerals that are all existing in the rocks. All this mica, all this quartz, hornblende, and several of them, there are so many of them, they are all in the rocks. And when soils form from the rocks, some of those minerals that will now form part of the soil that is formed. So the surface rock, when it's broken down into smaller pieces through this process of weathering, it is then mixed with moss and organic matter. Of course, you must have known by now that what gives rock or soil the color that it carries, especially when you see soils that is very dark in color, that dark color content of soil is impacted by organic material. When we talk about organic materials, in fact, let me start by saying that soil generally is made up of two components. We have the organic and the inorganic. Of course, when we talk about the inorganic component of the soil, they are majorly these minerals, rock minerals, and all of that. The reason why they are inorganic is because, of course, they are not living things. They are not living things that are either dead and decayed, in the case of plants and animals. When animals and plants that were formerly alive, when they die and decay, even though they are dead, we call them organic because they are components of a once upon a time living material. So we now call them organic. Assuming they were not living at all, they were not alive at all, then we call them inorganic or mineral materials. Over time, this creates a thin layer of soil. When these broken particles of soil, of rock, through the process of weathering, when they mix together with the moss and organic material, over some time, they create a thin layer of soil. Now, plants help the development of the soil. How does plant do that? The plant attracts animals, and when the animals die, their bodies decay, as I stated earlier. And now this decaying matter makes the soil thick and rich. These decaying materials in the soil, they are the things that make the soil to have nutrients. They are what makes them to be rich. That is why when you see a soil that is dark in color, you say this soil has enough organic matter in it. And as such, this soil should be rich. This soil should be fertile because of the organic material that it contains. It is continuous until the soil is fully formed. The soil then begins to support many different plants, because if these soils are not fertile, they won't be able to support plants. They won't be able to support crops when crops are grown on the soil. But however, we have what we call soil forming factors. Soil forming factors, they are just 5 factors that are known as soil forming factors. What are those soil forming factors? They include parent materials, they include climate, they include organisms. Then the 4th one is slope or relief. And the 5th one is time. I'm going to tell you some things about these 5 soil forming factors. The primary material from which the soil is formed is your parent material. That is why that name, parent material. That is the primary material from which soil is formed from. Most of the time, they are down under the soil. Most of the time, they could be rock. But as long as soils are formed from it, some of them may, of course, we have different kinds of rocks like igneous, like metamorphic, like the other, and the rest of them. Most of the time, they all have different forms. Some of them may not be as strong as the other ones, depending on the processes that led to their formation. However, each of these materials, depending on whichever minerals or whatever they contain, any process that happens to them that led to the formation of soil, it will also determine the kind of property, the kind of characteristics that soil that is formed will begin to exhibit as a result of the material from which it is formed. Also now, we have climate. What is the definition of climate? Some of you already know what we call or what we define as climate. Of course, climate is more like the average weather condition of a particular locality, of a particular location over some period of time, usually 30, 35 years and above. The particular climatic condition or the particular weather, the place. Now, weathering forces such as heat, such as rain, such as ice or snow or wind or sunshine and other environmental forces are what break down parent materials and affect how fast or slow our soil formation processes. The materials, there are what we call weathering forces. Weathering don't just take place. Rocks cannot just begin to break. There must be something that may happen to them. Sometimes it may be accumulation of water in the cracks in that rock. Over time, it will begin to mix up with some chemical forces, and it begin to gradually disintegrate the rocks. Sometimes it may be heat, extreme heat. We begin to alter some chemical composition in this rock, leading to disintegration, thereby soils begin to form. It may be ice, it may be snow, it may be wind, or even sunshine. Several other forces. All of these are collectively known as weathering forces. Now, when we talk about organisms or organisms, all plant and animals living in or on the soil, including microorganisms and humans, are what we collectively know as organisms. So the amount of water and nutrients, as well as plants that plants needs, affect the ways in which soils form. The way humans use soil affects soil formation as well. So all of these characteristics, all of these alterations, all of these effects or activities of man on the soil, or of animals, earthworms, snakes, lizards, and the rest of them, all living things, including plants, everything they do on the soil, all of them contribute to the formation of soil. The fourth factor of soil formation is what we call topography, or slope, or relief. The location of a soil on the landscape can affect how the climatic processes impact that soil. Soil at the bottom of a hill, we definitely get more water than soil that are on top of slope. And soils on the slope that directly face the sun will be drier than soils on slope that do not face the soil. All of these are all collectively, affect or determine what leads to the formation of soil. So slope is one of the factors of soil formation. Fifth factor of soil formation, which we call time, because all of the factors mentioned above, they assert themselves over time. Like when a rock, a water body covers a rock for over 100 years, definitely that rock will never remain the same, unlike the one that is not covered. So all of these things are all determined by some forces. They are all, and they happen over time. So soil profile continues to change from weakly developed to well-developed over time. For instance, when soils are formed, it will not be long. You now realize that so many things will begin to change in that soil. If you dig a profile pit now and leave it for quite some time, you go back again after some years or some months and begin to scrape the edges of that profile pit. You now realize some changes indicating that there are so many alterations. All these alterations, they lead to soil formation. Now, soil parent material, as I stated earlier, I tried to explain them earlier. Soil is formed from different parent materials. One such parent material is the bedrock. As rock become exposed at the earth surface, they erode and become chemically altered. So the type of soil that forms will likely depend on the type of rocks available. So the minerals in the rock and how these minerals react to temperature, pressure, as well as erosive forces. Now, temperatures inside the earth are very hot and they melt rocks or the lithosphere, which moves by tectonic forces below the earth's surface. Melted rocks will now flow away from the sources of heat and eventually cool and hardens. Now, during the cooling process, this mineral crystallizes and new rocks type will now begin to form. This type of rocks may be called igneous rock. They are called igneous rock because they are formed by the cooling and solidification of molten magma. So the original parent material or parent rock formed on the earth. Igneous rock under the right environment condition can change into sedimentary rock or even metamorphic rock. All of these things, of course, we know that our topic we are looking at today is soil forming rocks. So it has a lot. Soil cannot form without rocks or bedrocks or parent materials. So volcanoes produce igneous rocks such as the granite, pumice, and obsidian. That is what volcanoes produce. Now, when we talk about sedimentary rocks now, they are formed when older rocks are broken apart by plant roots or ice wedges and earth movement and become transported by glacier. Glacier is more like ice that is almost forming water. So when they are transported by this ice current or waves, as well as wind and the rest of them, so the transported particle then becomes bound together or cemented. So as secondary minerals grow in the space between the loose particles and they create a new solid sedimentary rock. We also have sandstone, limestone, shales. There are all types of sedimentary rocks that contain quartz sand, they contain lime, they contain clay, respectively. Now, metamorphic or crystalline rocks form when pressure and temperature below Earth's surface are great enough to change the chemical composition of sedimentary and igneous rocks. Remember now, it now has to do with a pressure and even temperature. When it becomes so high, to get to a point that it can change the chemical composition that are in a sedimentary rock. And when that happens, be it sedimentary rock or igneous rock, it can lead to the formation of metamorphic rocks. So metamorphic rocks now, such as quartzite, marble, slate, they form under intense temperature and pressure, but they were originally quartzstone, originally limestone, or even shale. Other types of parent materials that mineral soils form from are called recent cover deposits. They include alluvium, colluvium, aeolian deposit, glacial deposit, lacustrine deposit, loess deposit, marine deposit, and volcanic ash deposit. Talk about alluvium or colluvium. Most of them are deposits, especially in the coastal areas, deposit some things that were transported by flowing water after rain. So over time, when they accumulate, they form soil. So those are the alluvium and the colluvium deposits. Aeolian are deposit from wind. Deposit from wind, aeolian. Glacier are, deposit from flowing of ice and the rest. Lacustrine, the one from lake, and so on and forth. So weathering of rocks now. Weathering is a term that anybody who have done science in the past, who have done anything like science before, should be able to get used to the word weathering. You have learned it even in your secondary school days, and now it's coming up again. Yes, weathering is a process, and that process is the process of breaking down of rocks. And we say that there are two different types of weathering, which include physical weathering and chemical weathering. Now, in physical weathering is the breaking down of rocks, but what is made of, what it's made of stays the same. When rocks are broken down, there are no chemical transformation. The whole thing that rock is made up of, all the minerals that they are made up of, is still what remains, even though now at a broken down stage. However, when it is chemical weathering, it is still breaking down of rocks, but there may be changes. Changes are made in terms of the makeups of these rocks. For instance, a hard material may change to a soft material after chemical weathering. Chemical weathering occurs as minerals in rocks. As they are chemically altered and subsequently decompose and decay. So when there are decomposition, when there are chemical alterations, that is chemical weathering. So increase in precipitation or speed up of the speed up chemical weathering of minerals in rocks. Because when there are moisture in cracks of rocks, as seen in tombstone and monuments, that are made up of limestone and marble. Over time, you now begin to see some kind of breaking down. So in fact, water is an essential factor of chemical weathering, because also increase in temperature also accelerates the chemical reaction that cause minerals to degrade. You now see that water now, or moisture and temperature, are very, very important when we talk about chemical weathering. This is why humid tropical climates have high weathered landforms, soils, and buildings. We talk about climatic or tropical soils. Whenever we talk about tropical soils, the major tropical soils and soils of the humid region and the rest, or the temperate region, is because the soils from tropical regions are highly weathered soils. Why do we say that they are highly weathered? They have gotten to almost the last stage of weathering. And the reason for this is because in the tropics, we have extreme weather conditions, extremes of weather. Extreme weather condition means when rainfall comes, it is very high. When sunshine comes, it is very high. Anything that comes, it is very high. Those extreme conditions of weather, these are what leads to the decomposition or to this breaking down and weathering processes, leading to landforms, leading to different things that you may begin to see in the soil. Now, chemical weathering processes, remember that we are talking about chemical weathering. What are the processes that are involved in chemical weathering? Among the processes that are involved in chemical weathering, they include carbonates and solution. Carbonates and solution. This weathering process occurs when precipitation or rain combines with carbon dioxide to form carbonic acid. This carbonic acid is a very weak acid. However, it is capable of breaking down rock materials. So when carbon dioxide and water mix during rainfall and they are deposited on the surface of rocks, over time, because they are acid, even though we may say they are weak acid, they will begin to alter the chemical composition of these rocks, leading to breaking down. So when carbonic acid comes in contact with rocks that contains something like lime or soda or potash, the minerals calcium, magnesium, potassium in this rock will begin to change chemically into carbonates, and over time they will dissolve in this rainwater. We also have another process, chemical weathering process, that is known as hydrolysis. And this chemical weathering process occurs when water, usually in the form of rain, disrupt the chemical composition and size of the mineral and create less stable mineral, thus less stable rocks, and this leads to weathering. This rock now will begin to weather more readily rather than it would have done if not for this hydrolysis process taking place. Now we have another one we call hydration. Remember, all of them has to do with water, has to do with moisture. So now, when we talk about hydration, it's also when water combines with compound in the rocks, causing a chemical change in a mineral structure, but more likely, we physically alter a mineral's grain surface as well as their edges. Then the next process now in chemical weathering is the oxidation. Oxidation. This process occurs when oxygen combines with compound elements in rocks to form oxide. And when an object is chemically altered in this manner, it is weakened and appears to be oxidized. It is oxidation. So there's what we call redox reaction. Redox reaction is oxidation and reduction reaction. When we talk about oxidation, oxidation has to do with presence of oxygen. When we talk about reduction, reduction has to do with removal of oxygen. So when there is presence of oxygen in the rocks, mix up this process, when this oxygen combines with some of the elements in these rocks, it will begin to alter chemically. Sometimes it may weaken these minerals. It will now lead to the formation of soil. Spheroidal weathering, this is when water penetrates through cracks in the rocks and dissolves the cement that binds particles together, and also erode sharp edges and corners of rocks, making a rock to appear spheroid. Now, we also have what we call physical weathering. Said we have two basic types of weathering. We have the chemical and the physical weathering. And I've just finished explaining physical, I've just finished explaining the chemical weathering. However, now talk briefly about physical weathering. So rock broken and degraded by processes other than chemical alterations are what we call physical or mechanical weathering. So when a rock is broken into smaller pieces, exposes more surface area of the original rocks, thereby increasing these exposed surface areas of rock, we increase the weathering potential of this rock. What are the things that lead to physical weathering? Something like animals and plants can lead to physical weathering. Remember, the difference between physical weathering and chemical weathering is that when the chemical composition of the rock being broken down now, that is being weathered now, when the chemical composition does not change, it is physical weathering. But when it is changes, when it leads to formation of new products, changes in the chemical composition of the rocks, it becomes chemical weathering. When animals burrow into the air surface and move rock fragments and sediments on air surface, aiding in the disintegration of rocks as well as rock fragments, they are physical weathering. They are physical weathering. Sometimes they may even say they are biological weathering. But as far as the material that is being disintegrated is not changing in their chemical composition. Now, we also have fungi and leeches, which are acid-producing microorganisms that live on rocks. And sometimes they dissolve nutrients. They dissolve nutrients such as phosphorus, calcium within rocks. These microorganisms assist in the breakdown and weathering of rocks. Yes. However, also now, physical weathering process also includes crystallization as water evaporates, moisture from rocks located in arid climates, mineral salts develop from mineral crystals, and the crystals grow, spreading apart these mineral grains in the process, and eventually they break apart these rocks. Now, temperature variation, of course, you know very clearly where in the desert area, for instance, it's usually very hot in the day and very cold in the night. So assuming there are rocks in those areas, in the day, due to the high temperature there, you now realize that the rocks there would have absorbed this moisture, this temperature in these desert areas. And in the night, due to rapid evaporation of all these temperatures and all of that, there's extreme cold. So this extreme temperature and extreme cold condition will ultimately lead to the breaking down of this rock material, because the weather, the effect on it will lead to the disintegration of this rock material. So minerals in these rocks expand and contract in climates where temperature ranges are extreme, like in glacial region of the world, or when exposed to extreme heat, like during the forest fire. So crystal structure of minerals becomes stressed during contraction and expansion, and the mineral crystals will begin to separate. We have uploading and exfoliation. Cracks in rocks appear when pressure is released, as overlaying rocks or sediments are removed, thus allowing the expansion of these newly exposed rocks. So we also have exfoliation, and exfoliation occurs as sheets or slabs of the cracked rocks slip off and become further eroded. Conclusion: a rock that is weathered into new minerals but still looks somewhat like the parent rock is called saprolite. If saprolite fragments are subsequently removed from the site by water, wind, gravity, or ice erosion has taken place, of course, it leads to formation of soils. It leads to formation of soil. So you now see that soils, remember our topic is soil-forming rock. Soil-forming rock is what we use as our topic, soil-forming rocks. So that is some of the, and in the actual sense, what leads to the formation of soil is the process of weathering. And we have chemical weathering and physical weathering. And of course, chemical weathering, when the chemical composition of the rock being weathered remains without changes. However, if there are changes in this chemical composition. It is no longer chemical weathering. If there are no changes, it's no longer weathering. It becomes physical weathering. If there are changes, it's chemical weathering. So just as we are rounding off already, I don't know if there is any question. If there is any question, you just unmute yourself and go ahead and ask your question, please. And unmute yourself and let me know if you were able to understand the little effort I made to explain these soil forming rocks to you. Any comment, any question? Musa, Umar, Ajayi, Raphael, Oluwatoyin. So, anyone, any comment, please? I just need you to make a comment, please. No comments?
No comments, sir.
Okay. Thank you very much, Ajayi. So please, in my course page, we have the instructional videos. Always go there and watch it. If possible, watch the instructional video for the next class. The next class we are going to have likely the 4th class. You can just watch the instructional video before the class. Each of those things, it will help you to understand more of what we are trying to explain. So thank you very much for being part of this today's facilitation class. See you same time next week. Remain blessed.
Bye-bye, sir.
Thank you very much.
Good afternoon, sir.
Yeah, Oluwatoyin, right?
Yes, sir.
How are you?
I'm fine, sir. I have a question. Under this biological weathering, yes.
Yeah.
There are some calculations under particle and bulk density. How do you go about it, sir?
There are calculations under
the bulk density.
Okay, that should be in the last class, right? Or is it in this class?
Because
we are not talking about bulk density. We are not talking about bulk density today. We talked about bulk density in the last class.
Oh, okay. Because I could not, because the network was bad then. So, oh, all right, sir. I'll go back to the last video.
Yes, we talked about bulk density. Go and watch the instructional video. Go and watch. What you should know about bulk density is it's usually measured in gram per cm cube. So it is mass over volume. So you calculate the mass. Mass is just the weight of the soil. Then the volume is, of course, we normally use what we call core sampler to collect soil the way it is in nature. We collect it, then we now measure the volume. After that, the soil must have dried. We now measure the volume. After that, you now divide that mass over the volume and get gram per cm cube. So that's the stuff.
All right, so, thank you, sir.
Yeah, all the best. Thanks for your question. So please study very well. It's gonna be a walkover if you know what to do. If you do your instructional video, you attend the classes, you read your course material, you really have a good time studying this course. So thank you for being with me today, and see you same time next week.
All right, sir. Bye-bye, sir.
Yeah. Bye.